Okay. So let's take a simple example that I need to store marks of you all students. Fine. If I want to store your marks, like we have some 78 students in our class, to save marks of those 78 students, one thing is I make 78 variables, and somehow let's say I name the variable like your roll number or your name, and with that variable with every variable I'll save your marks, right? And suppose like we have marks only in integer number, not the float value. It is like a fixed defined number. So that way I'll be creating 78 integer variables, fine. And that is fine, acceptable, because that is how we will be doing it. But that is so cumbersome to manage that 78 variables and storing, referring every roll number, referring every variable with the complete with your roll number and getting that marks. Fine. So it is quite cumbersome approach. To solve such approach that you are saving a same type of data, a number of same type of data, like I want to save your marks for all your students, like marks would be same certain value for same integer value for 78 students. In that certain cases we use another derived data type, that is arrays. Another derived data type, that is array, that we call as array. So write down, we define an array as a collection of elements of same data type. Array is defined as a collection of elements of same data type that are stored in continuous memory. Fine? That are stored in continuous memory. That is how we define an array. Fine? And we know it is one of the very first derived data types that will be starting. Ab tak humne sare, we have studied only the basic data types. Now we are moving to derived data types. The first one we are doing, we have covered pointers. Now we will be doing is arrays. Right? So array is basically a collection of elements of same data type that are stored continuously. Fine? That is what we want to say with an array. Now look here. Fine. Look here. If we say how we declare, basically how we declare, what is the syntax of array declaration? Fine. You write the data type. What could be the data type? Data type would be the same for data types: int, float, character, or double. Right? These are the four possible basic data types के ही आप array बनाएंगे. Fine. Data type space array name. Array name would be same rules will be followed as for a variable name. Then once you put square parentheses, these are called square parentheses, and in this here you will write a integer constant. Integer constant, and that integer constant would define the size for this array. What does that mean? Let us look here. This is a very basic example of declaring an array that is named as A, and the size of that array is 5. That is how we declare it. It is of int data type. Fine. That means what this line informs you is that you are creating an array with name A of size 5, and that is of data type integer. So what this will do in memory is, in memory, now you will create a space of 10 bytes. Let's say up to here. A total space of, this total space would be of 10 bytes. Fine. And this total space is given a name A. So that is an array of 10 bytes of space is created. Now further, this size 5 denotes you that this size of 10 bytes is actually segmented in 5 sections, each of 2 bytes. One, two, three, four. Okay, I should have not drawn this. Not this one. Let me quickly do it again. 10 bytes of space is allocated. Each is divided in a group of 2 bytes. 3, 2, 3, 4, 5. 5 sections. And this is complete your array A, space for array A of size 10 bytes. Fine. Now, this first space of 2 bytes, you can access like array name and in square parenthesis 0. If you write it this way, array name, that is A in this case, and in square parenthesis 0, then we'll be accessing this first 2 bytes out of this complete 10 bytes storage. Fine. Similarly, I can refer this second storage of 2 bytes as A and in square parenthesis 1. This way, we'll be accessing the second block of 2 bytes. Same way, this third one will be dealing with A in square parenthesis 2. This one is A and in square parenthesis 3. And the last block of 2 bytes we can access as A and in square parenthesis 4. That is how we access individual complete array element that is of 10 bytes, and that 10 bytes we can visualize as like 5 blocks of 2 bytes each, and they are continuously saved in memory. That's important. Fine. Another thing, how we individually access individual element, fine, individual block of 2 bytes, that is how we do it. If we are writing A and square parenthesis 0, then we are accessing the very first element. A square parenthesis 1, then the second, and so on and so forth. Is that simple? This is the declaration syntax. This is a simple example of declaring an array. And once you declare an array like this, then what you are actually doing is you are creating total size. You are creating int type of array. Int type means that every element you will be storing in that array will be an integer value. Plus the name of array is A and size of array is 5. That means total 5 integer elements you want to save. Fine, that will be the size of array. Fine. So that is how we computed the complete size of array is 10 bytes because 5 integers we want to save. One integer is taking a storage of 2 bytes. So 5 integers would be taking a size of 10 bytes. That is how we are doing this. 10 bytes of storage. Plus that is how we are accessing these individual elements. We all good with this much? Fine. Next important, interesting point comes in is how you refer what this 0, 1, 2, 3, 4, what this 0, A0, square parenthesis, A0, A1, so on and so forth, A4. These are used to access individual elements. When we want to write something here, then we will write A0. That means we are telling compiler to fetch here, the value over here, equal to 5. Once we end semicolon. Once we do that, then value 5 would be written at this block. Fine? Fine? Simple है? Okay. अभी 2-dimensional array की बात बाद में करेंगे. For now, just ignore these 2 lines of code. Just focus on these 2. Fine? Now, another thing is this 0 to 4 we call as index value. Now try to understand index value. What does indexing do? See, for arrays, basically you can just understand it for arrays. Your indexing will always start from 0. Index value will always start from 0 to size -1. Size is whatever the size of array you are declaring minus 1. So your index value will range from 0 to size minus 1. If you are creating an array of size 5, so index value will be 0 to 4. If you are creating an array of size 10, your index value will be 0 to 9, so on and so forth. And we understand when you are writing index value 0, then you are referring the first element of that array. When you are writing index value 1, then you are referring the second element in that array, and so on and so forth. That's simple? Fine. So that is what an array is. Array is just a collection of elements of same data type, plus they are stored continuously in memory. You can see this. These 10 bytes is stored continuously. 2 bytes, then 2 bytes, then 2 bytes, so on and so forth. They are stored continuously in memory. Fine. Because this is one data type, one variable. Fine. Which is further of storing 5 integer variables. Then it is how it's declared. What is this declaration syntax? You define the data type. Data type is what kind of values you want to store in that array, name of array, and size of array. That means how many elements of this data type you want to store in this array. Fine. Like the example we discussed, that for your class midterm marks I want to store, then I will be creating precisely float, let's say mid marks, in size would be 78, and semicolon. Fine. Fine. Can anyone tell me what will be this the size of this mid variable, mid array? What would be the size of array mid, named as mid? Let me see if anyone has answered, but it will be 78 into 4 bytes. This would be the total size. Fine, and we all understand how it is. Fine, okay. We understand what indexing is. Simple thing. Okay, let's go next. Okay, that is, we just discussed how the elements are initialized. How the elements are initialized, we understand that with the index. Specifying the index value, we can initialize the elements. This is fine. Same way, okay, just you need to understand this syntax. We are another syntax we need to understand, that we are declaring as well as initializing. Fine. As we were doing declaring a variable, then initializing a variable with a value, as well as we studied declaration and initialization in the same syntax. So this is array declaration and initialization syntax. Here we are declaring an array of size 5, use assignment operator, and in curly parentheses, by putting a comma, you can put the values of all the elements. What this will do, same thing in memory, it will create an array A of size 10 bytes. Fine. That 10 bytes you can visualize as continuous block of 5 each of 2 byte space. Fine. And once you are initializing it, this is the initialization syntax. What it will do is assign value 1 to the first element of the array, assign value 2 to the second element, 3, 4. Okay, actually, sorry, it is 5, up to 5. 5 elements are created. So 5 to 5th array. Fine. Fine. After this one, fine. This is okay. And this syntax is also a valid syntax, because it says if you are initializing an array at the time of its declaration, then specifying the size here, specifying the size of array in square parenthesis is optional. It is optional to you. You may or you may not. Right? So both of these syntax are correct. Both of these syntax are correct. Fine. We all good with till here? Okay. Let's discuss this very simple program and tell me what will be the output. Just go through the code and let's discuss what will be the output. Quickly, everyone. What will be the output? See, once you run this code, on the output screen, see, this I'm specifying your memory, and that to be the output screen. First line of code will be executed, this one. Here you are declaring two integer variables. One is an array and another one is a simple integer variable. So what this will do is, it will create accordingly respectively size for array A of integer type, size 5, and initializing those values as we did last time. It will just initialize those values to 1, 2, 3, 4, and 5. Fine. And it will also declare another variable, integer variable, named as I. We all understand that? Fine. As well as, just we understand, for our understanding, let's suppose the base address for this array was 200. Same thing. So byte with address 200 and 201 will be referring this first element of the array, which we denote as A square parenthesis 0. Fine. Okay. And 202 and 203 byte number will refer this 2 bytes of space element, which is the second element of your array, which we refer as A in square parenthesis 1, index value 1. So we'll refer the second element of array. So on and so forth. This will be 204 and 5. This will be 206 and 7. And this will be 208 and 9. Address for these 2 bytes. Fine. Same way, it will be A in index value 2, A index value 3, A index value 4. The fifth element will refer this way. Same way, let's suppose address for I is 400. That's simple. And nothing is initialized here as of now. That simple will happen with this line of code. Fine. Then this is simple a printf statement. So it will print arrays simple. Then we have a loop statement. As the 4 keyword is encountered, we understand it is a loop. In parentheses, we first initialize. This is your, now I will be acting as the loop variable. So I will be initialized to 0. I is less than 5. Yes. So this is the only statement in the body of for loop. We understand that, right? This is the only statement in the body of the for loop. So it will execute this line of code. That is, it will print A square parenthesis %d, fetch the value of I, that is 0 here, A0 semicolon, %d, fetch the value of A0. What is the value of A0? It is 1. Then it will increment, it will go out of the loop, increment the value of I, again check, it will be 1 here now. Check I1 is less than 5, yes, again print this statement, A1 semicolon 2. So on and so forth, the loop will keep on executing till A2 semicolon 3, A3 semicolon, value of A3, third element is 4th element and third index value is 4. A4 index value 4 is equal to value 5. Is that good? Are we all good with this? Fine. You need to pay attention. This is how it is happening in the memory. This is variable A space total from byte 200, byte with address 200 to 209. that is 10 bytes of this space is for variable A, and that is how individual elements are addressed. Fine. And that is how your element I is addressed. Fine. Simple, eh? Clear, eh? Okay. Now try this one. It is just the same program as the previous one. Just now, instead of just initializing the elements of array and printing them, you will be taking elements of array. You will be taking, with this loop, you will be asking user to enter the value of elements of array. Right? And just the thing to understand in this is this line of code. In scanf, as you will passing individual element, if we want a value in variable I, integer variable I, so we write here usually address of I, address of operator, and the variable name. Now we want individual elements of the array. We ask user to individually enter every element of array. Right? So it will be entering every element of array. So it will be, we are running a loop in the index value. And that is how we use address of operator, that address of array index value A0. If I'm writing A0, so we now understand as in the previous example, if it is A0, then its address was 200 and 201. So it will pass address 200, and at that particular address, whatever value user is entering, that will be placed. Right? Same when you are passing address of A1, that is how with A index value 1, we refer next 2 bytes of space, that is 202, 202 and 203. So it will pass address 202, address of operator will fetch address 202 and place here whatever value user is entering, so on and so forth. Right? And similarly, you will print those values over here, as we are doing in the last program. I think we all are good with this much. Fine. For now, ignore this line. For now, we'll come back to this line again once we do the array to pointer. But we'll see, even if you just here, just for your information, if instead of writing it this way, if you write only A plus I, even that syntax will work the same way. Why that is doing so, we'll discuss right away. Fine. Till this point, everyone is okay with that? Okay. Now let's discuss two-dimensional array first. Right? We all have studied matrix in our 12th standard, 11th standard. Fine. This is simply a matrix. Fine. Fine. In matrix, we understand that we have a certain number of rows and a number of columns. Like for this example, we have m rows and n columns. And that is how we denote the size of matrix, m by n. Fine. M will be, the first element will be your number of rows. Your second element will be number of columns. Simple. Same way, this is another your matrix. Fine. And the dimension for this is 2 by 3. Fine. That's simple. That is, we already know from the mathematics. Now, view address, let's say this M is the name for this matrix. You address this element as M11. The first one tells you that the first row, and second one tells you first row, first column of the first row. So that is how you address this element. Same way for this element, you write M12, and for this element, you write M13, so on and so forth. Simple. That is how you individually refer to every element of the matrix. Clear? Simple. Fine. Now, if you pay attention here, whatever we have done here is simply, this is simply a one-dimensional matrix. Your array are just this simple one-dimensional array. Array B we have like one-dimensional, two-dimensional, multi-dimensional. 1D I'm writing to represent one-dimensional array like this one we have just studied. Then we have two-dimensional arrays. Two-dimensional array would be something like this matrix, two-dimensional matrix. We have three-dimensional, four-dimensional, and so on and so forth. Multi-dimensional arrays we do have. Is that okay? We all fine with this? Fine. Now, that is how, come back to matrix. That is how we represent matrix in mathematics, how dimensions we represent. That is how we represent and how we access individual element of a matrix. Fine. Now, when we go on arrays, with the simple one-dimensional array, we understand if we are creating this one-dimensional array, we referred it as, we represented it as in memory, same 10 bytes, 2 block size, fine. And however, there, how we refer the first element is, instead of A1, if it would have been a matrix in mathematics, we would have written A as a subscript 1. But in C language programming, when we are talking about arrays, we refer this element as A in square parenthesis 0. Fine. Second element in matrix, in mathematics, we talk about A and subscript 2. However, in programming, we write it A in square parenthesis 1. Fine. So simply I want to say with this concept is, in mathematics, you use this notation, and if you say indexing of the elements of your matrix begin from 1 to whatever the size of matrix was there. Fine. However, in array, this indexing will begin from 0 to size of array minus 1. As we discussed, fine. For this, indexing will begin from 0 to 4. Fine. Fine. So same way, now if we'll be creating if we want to one dimension clear hai, its relation with matrix, one dimensional matrix is okay. Right? Now, if we talk about two-dimensional array, right? If we have a two-dimensional array that we understand, two-dimensional will be space like this one. Fine. It won't be a single row or single column. It will be a space like this one. That is how we represent a two-dimension data set. Fine. So it is a two-dimensional array, then it will be having a certain number of rows and a certain number of columns. Fine. So that is how we write the syntax. That is the syntax, journal syntax for a two-dimension declaration of a two-dimensional array, and this is a simple example. Fine. Now syntax says you will first write the data type, space, array name. Then here you will be using two square parentheses. The first square parenthesis, you will specify how many number of rows you want in that two-dimensional array. Fine. You will specify the number of rows you want. In second square parenthesis, you will specify how many number of columns you want in that array. Fine. And again, we understand this R and C will be integer constants. Pay attention. It will be integer constants. Fine. Okay. So this is an example. So this will create visually, this will create an array of size 2 by 3. Fine. And the first element you will refer as 0, 0. Okay, let me just do it again. How this you visualize is, you will visualize this as matrix, two-dimensional matrix, fine, of size 2 by 3. That means 2 rows you will be having and 3 columns you will be having, fine. So this will be the, let's say I'm writing 1, 2, 3, fine, and 4, 5, 6. Some values I have initialized. Right now I haven't initialized it here. Just suppose these are the values. Fine. Then the first element, it is your array B. The first element you will refer as B0 in first square parenthesis and second 0 in second square parenthesis. That simply I want to say is, again, these are the rows indexing. Fine. Rows ka indexing will again begin from 0 to number of rows minus 1. And this will be the column indexing. Again, the column indexing will begin from 0 to number of columns minus 1. Fine. So the element in the first row and first column, the index value for row will be 0 for that, and column will be again 0 for that. Am I clear in this way? Am I making sense? Fine. Fine. Is this okay?
Yes, ma'am.
Do I need to do it again? You all good with it?
No, it makes sense, especially when we look at the 1D and how it connects with the 2D.
Right. So this is, we all understand how it would be 0, 0, B 0, 1. Second element will be index to be 1. Then B, third element will be B0, B2. That is first row. Then second row elements will be, it will be second row. So index for row is 1. And this is 0, B, 1, 1. That is second row, second element. This is B1 in first square parenthesis. That is second row. And if I write here 2, third column. Fine. That is how precisely every element will be referred. Is this clear? Fine. Now move to next concept. That is how we visualize it. Fine. That is how we visualize a two-dimensional matrix in mathematics. Fine. Just the indexing is changing. Indexing value is changing. Here we were indexing from 1. Here we are indexing from 0. Fine. Now another important thing is how this will be saved in memory. How you save it in memory. Because we understand that memory is just a sequence of bytes. So how you store this elements to memory? That's very interesting thing. We say row major storage. We say row major storage or column major storage. This is actually concept of OS, that is operating system. It is property of operating system and compiler details that you will be storing these elements in row major concept or column major concept. But the C compilers use row major concept. Okay, now I'll tell you what does that row major concept mean. As we know, our memory is basically a sequence of bytes. Fine. So row major storage says that you will store these elements in continuous storage of memory in the sequence of their rows. That you will store all the elements from first to last, all the elements of first row first. Then you will come to second row and store from the first element of second row to the last element of second row. That means the first 2 bytes will be for this element. Second 2 bytes continuous, next consecutive 2 bytes will be for this element. Next consecutive 2 bytes will be for this element. Next consecutive 2 bytes will be for this element. Next consecutive for this, and next consecutive for this. Right? This is called row major storage. That means you are making storage in memory for a variable in sequence of the rows. First row elements, then second row elements, then third row elements, so on and so forth. Fine. So in this memory, for this, actually how much space will be created for this? 6 into 2, 12 bytes. Fine. So out of these 12 bytes, the first 2 bytes will be for this element. That is B0, 0. Next 2 bytes storage will be for this element. That is B0, 1. Right? And so on and so forth. That you understand. And this kind of storage is called row major storage. Right? Up to only here you need to know. You need not to know column major. I'm just for your information in one statement, I'll be telling you. Fine. Now, if the storage is column major storage, so it goes just like you will be making storage column wise. First column elements, then second column elements, then third column elements, and so on and so forth. So in that case, this continuous 12 bytes of storage would be first this element will be stored, second this will be stored, third this will be stored, fourth this will, fifth this one, sixth this one. Right? That will be column major. But in C compiler, we use row major storage. Is that simple? This is how you visualize it, a two-dimensional array, but actually that will be storing in memory space. Clear? Clear? Simple? Fine. So let's start, do a simple program for two-dimensional array. Before that, let's just discuss. That is how we address individual elements of a two-dimensional array. We all understand this. The first index value is you will be specifying which row. Second index value, you will be specifying which column in that row. Right? As in matrix we are doing. Simple. Fine? Okay. Now, just look here, the same. If you declaring and initializing at the same time. Right? Once you are declaring and initializing the elements at the same time, this syntax is followed. This syntax is followed. Fine. With this part of code, you have declared an array of size 2 by 3. Fine. That means 2 by 3 is 6 elements you will be storing. Fine. And equal to, in square parentheses, separating by comma, if you write 6 integer values, then you will be assigning these 6 integer values to this array. And again, this assignment as well will be in row major format. That is, this first element will be the A00th element. This will be A01. This will be A02, so on and so forth. Fine. And this will be A10, A12, and A11 and A12. Fine. Simple. Okay. Other, like this one, you can also use this syntax. Here you are explicitly telling that this will be the first row and this will be the second row elements. Fine. Both the syntax are correct. They are just different ways of saying the same thing. Fine. Okay. As we say that, okay, we will be conducting a class for CO102, or if we say, okay, we'll be conducting class for programming fundamentals, because both are named for the same thing. So both saying the both things remain the same value. So this is two different syntax are allowed, how you declare and initialize at the same point of time. Right? Next, just pay attention here. Again, specifying number of rows is optional. And when it is optional, when you are initializing the array. As we were talking in the last example, one-dimensional array, if you are initializing it at the same time, then specifying the size of array was optional. Same way, in two-dimensional array, when you are initializing it at the time of its declaration, then specifying the number of rows is optional. Right? Just pay attention. Only specifying number of rows is optional. You have to specify the number of columns. You have to specify the number of columns. Right? That syntax. That is another syntax. Simple. So let's do a very simple program. This comes interesting part. It talks about nesting of loops. Right? See. Let's quickly discuss this. This first line of code will do the same thing. It will declare 12 bytes of space for array A and initialize 12 bytes are for 6 integer elements, and initialize those 6 integer elements to these, and will also create an integer variable I. That is how it is doing in memory. Let's quickly do it. This is I and this is A. And I'm just writing few, not all, okay? I hope you assume that. 5, 6. Actually, I just had needed 6 space. Sorry. This is array. Right? And this first element is A, 0, 0. And second element, that is another next 2 bytes of storage, is A, 0, 1. And so on and so forth, we understand. Right? Now, once you understand this array is 1, 2, 3, that is how we logically, this is how it is going in memory, and actually visually we understand it this way. That is your array elements. Fine? Okay. Now, if I want to print this array in the same format, fine, I want this to be printed in this way only, that it will print array A is there, where first 3 elements are this one, then next row will be printed this way. Okay? So for that, whenever you want a display in 2-dimensional, you will be using indexing of loops. Fine, you will be using indexing of loops. अब तक हमने जितना whatever we have discussed about the loops, we were just displaying first n natural numbers, first n even numbers, first n prime numbers, so on and so forth. Fine. So not prime numbers, other than prime numbers, whatever we were doing, for that we were just using one loop, and in that only we were putting the code and logic, and it was printing. It was like a linear logic is followed. There is no like 2-dimensional logic. Rows and columns are nowhere related till that. Right? Now, or actually you would have done in the class, in the lab, some programs like printing some specific patterns. For that you would have implemented indexing or indexing of loops. I believe that you would have done that. If you have not, we'll keep an extra class for that separately, so that we can, those who do not understand that well will cover it there. Right? For now, just let's focus here. For now, the first, just try to understand, whenever you will be using a 2-dimensional array, you will be using indexing of loops. Right? And the outer loop, this one we say is outer loop. Outer loop we will be using for specifying rows of that array. And the inner loop we'll be using to specify columns. Fine? And for like this array, the indexing of rows will go from 0 to 1. We understand that? Indexing of rows will go from 0 to 1. Fine? So same way, for outer loop, you will put the code from that your index variable for the outer loop will be starting with 0 and will be less than number of rows you have. Right? You write here less than 2, or you write here less than equal to 1, because that is will be the index values for the rows in that array. Fine? 0 or 1. You understand that? Fine. Now, inner loop we are talking about. Again, inner loop indexing will go depend on the number of columns you have. It will definitely start with 0 to whatever columns you have specified, that minus 1, because 3 columns means 0, 1, 2. It will go to 2. Fine. So accordingly, you will specify condition here like j will begin from 0 and will be less than 3. Simply the number of less than the number of rows. Number of columns. Here it was less than the number of rows. Right? That's simple. And if you see, if I don't specify curly parentheses here, then only this printf statement is in the body of this inner for loop that we already know. Right? And this printf statement will be in body of this for loop that we already know, that we discussed already. Fine. Now, once you execute this line of code, what will happen initially? For I value 0, j will be 0, and it will print element on output screen. It will print, okay, H5, please make a correction, put here \t. Change this \n by \t because I want array to be displayed in this fashion only. Right? So first it will be printed as A0. Okay, another error is there. Please make this line of code as a correction here. \t A %d, then square parenthesis close, another square parenthesis %d, square parenthesis close, equal to %d. Put this in the printf double quotes. Make this correction. Accordingly, we'll be executing. Right? So for first %d, it will fetch the value of I, that is 0. And for second %d, it will fetch the value of j. Again, initially it is 0. And it will print value of A00. A00 is 1. Right? So it will print 1. That is how it will print the first element. Then it will go to the inner loop again, increment the value of j. Now the value of j is 1, but till now value of I is still 0. So it will again come in the loop and print this statement. In next with \tab, it will print A01 will be equal to value of A01 is 2. So it will print 2. Right? Same, it will again increment value of j. Now j is 2, which is again less true for this condition. Will again print space tab and A02 equal to A02 element, that is 3. So it will print 3. Right? Again it will increment value of j. Now j is 3. 3 is not less than 3. So it will come out of this loop. Out of this loop, it will come to this statement and it will print \n. So the control will just come to next line. Right? Then again it encounters closing parenthesis for this loop. So it will go on incrementing the value of I. Now the value of I is set to be 1. We'll check the condition. 1 is less than 2. True. So it will enter the body of this for loop again. First statement it will execute. Again a for keyword. Again a loop will be beginning. Again it will initialize j to be 0. Fine. And we'll check the condition for j to be less than 3. Yes, 0 is less than 3. So it will again printf this statement and print A10 because here value of I is 1 and j is 0 equal to A10, which is value 4. Again increment value of j. Will go check the condition, again true, again print this statement. So on and so forth, it will print twice. A11 equal to 5. A12 equal to 6. After this execution, at this point of time, the value of j was 2. After this execution, it will go and check value of j, increment again. It will be 3. 3 is not less than 3. So control will come out of this for loop to this line of code. It will print next line. So control will come here. Fine. Again, it will encounter closing parenthesis. Again, increment value of I. Now, value of I will be incremented from 1 to 2. It will check the condition. 2 is less than 2. No. So control will come out of this for loop. After this, it is closing parenthesis. Just your program execution is complete. Right? And this is how your output will look like. You must execute this code. This code and the next code I will be telling you. Must execute this code. Okay? That will give you understanding how things are flowing. And if you don't understand it this way, do dry run. Fine, do dry run so that you better understand what control is going to which line, then to which line, then to which line, where. Fine. Is that simple? Let's go next. This is the same code, very much same to this one. It's just now we are asking user to enter the values. Here we were just initialize the array. Here we are asking user to enter the values and then we'll be printing this array. Right? So try both those programs. Okay. Next. This is the interesting part. This is very, very interesting. Once how we use pointers to an array. First, we'll keep this discussion today up to first one-dimensional array only. How we use a pointer to an array. How we use a pointer with an array. Such that a pointer will be pointing to an array itself, and with the pointer itself, we can access all the elements of array, or we can play with the elements of array. We can change the value, we can access the value, we can do whatever we want to do with those values. Right? That is next thing we want to do. So that is called pointer to an array. Let's discuss pointer to an array. That's the interesting part. Look here. What these two lines of code are simply doing. This is, we are declaring an array of size 5 of integer data type, name A. Here, we are creating an integer pointer with the name AP. Right? That's simple. That's simple. Now, with this, we understand it is A from address 200 to 209. 10 bytes of address space for array A. Same way, we created a pointer. Let's AP, we named it a pointer. Let's suppose it's at address 400, 400 and 401. Right? So now, after this line of code, if we put this line of code, let's say we are saying AP is equal to. अभी इसको छोड़ते हैं, अभी इस पे आते हैं. That's simplest for you to understand. Address of A0. First discuss this. What this line of code is doing, we are initializing the pointer, fine, and we are saying put in the pointer what to put. Address of A0. A0 is the first element of this array, fine. Its address, find its address, which is address 200. Put that address 200 in AP. Fine. That's simple. That you say it this way, or you say it simply that we have an array. In books, you find this notation. We have an array of 5 elements where this is A0. Fine. This is A1. So on and so forth. This is A4. And we created another pointer P. Now it is pointing to the first element of this array. You use this notation, or you use like P is another pointer which is storing the base address of first element. So it is pointing to array. This we technically call, now we have initialized pointer to point to store the base address of the array. Fine. This base address of first element of the array, and this we technically call as like pointer AP is pointing to this array. Fine. Technically we say it this way. Fine. Because if you print a static AP, what it will do? As we have practiced enough the pointers, if you write a static AP, so it is like dereferencing the pointer AP. It will fetch the address 200, and whatever the value at address 200, it will fetch you that value. What is the value of A0? Simple? Simple? Is this simple to everyone? Fine. Now, if after this line of code, after printing this, here, if I do AP plus plus, then again I print dereference AP. This is, I am printing it, okay? Again, I did a increment operation on pointer AP, and again I want to print. I'm using printf for this, okay? For now, I'm just talking in simple language. Again, I'm printing the value of dereference AP. What do you think what value it will print? What do you think what value it will print? Anyone, any answer? Let's see. Very good, Nikhil. Fine. This Nikhil answer is more appropriate. Okay, for this one, anybody any idea what AP will print? Just go with your logics what we have studied. If you are doing AP++, where AP is an integer pointer, incrementing it will change the address by 2 because size of integer is 2 bytes. So now instead of storing 200, it will store 202. Fine. Are you okay with this line of code? Let's give it a second. See, after this line of code, AP will have value 202. Are we all good with this? This is same from the last class explanation. Now, if we print dereference AP, then what does dereferencing means? Dereferencing is nothing big deal. It simply says whatever is the value in AP, fetch the value at that address. So at 202, this was the first element. You look it in this way or this way, whatever you are comfortable with. This first element was at address 200 and 201. We know that 2 bytes of this for first element A0 element. Yeah. Next 2 bytes, that is address 202 and 203, is for A1. Fine. Is for A1. So whatever the value for A1 was there, that will be printed here. Whatever the value for element A1, that will be printed here. Are we good with this, everyone? Are we all good with this? Fine. So that is simply, we will be using pointer like this way or another way. I'll tell you the other way. See, simply look here. We declared an array. We declared a pointer. We initialize the base address, or you can say the address of first element of array to pointer. Fine. This we technically say now your pointer is pointing to array, declared array. Fine. Next thing we want to do is with this I want to tell you these two syntax as well. What these two syntax say, if instead of writing this, I write this, even that is acceptable. I write this, even that is acceptable. Both these 3 things are correct, and all these 3 things will do this same thing. That AP, it will assign value in AP equal to 200, which is the base address of your array. Fine. These all 3 syntax are correct. Fine. Okay. Just you need to pay attention, more particular attention here at this syntax. Why so? Because if we say, okay, AP is equal to A, how it could be true? Because we said in the recall from the last lecture, we said if the left-hand side operator, the value in the left-hand side variable or operator, whatever you're using, variable, it is an address, then right-hand side should also be an address. So is that mean your variable A is a pointer? Because this is a pointer we have declared. Is this a pointer? Does it arise that question to you? In these 2 syntax, there is no issue because we are using address of operator to fetch the address. So we understand. Okay, A, it is fetching the name of the array, and we are passing the address of that particular array to the pointer. But in this case, how the syntax is allowed? If this syntax is allowed, is A pointer? Because it should be logically allowed only in the case because left-hand side is talking about an address, then left-hand side is a pointer, so it is storing some particular address. If you are equating anything to it, then that should also be a pointer, or that should also be talking about an address value, not anything else. Fine. So that thing arises a question whether variable A, if you are writing it this way, is this A simply when we write, is it a pointer? Answer to it is yes. whenever you declare variable, whenever you declare an array, pay attention, whenever you declare an array, the name of array itself acts like a pointer to this storage. Whenever you declare an array, you create a particular storage, specific size of continuous storage in memory, and the name of array also acts as a pointer that is pointing to the base address of this array. Fine, base address to this continuous storage of specific size, and the name of array will also act as a pointer pointing to storing the base address of this array. Fine. Am I clear with this? This is very important to understand. Fine. Fine. That is why this syntax is allowed. That's the concept behind this syntax. Clear? Clear? Okay, next go here. If we write AP plus 1, what does AP plus 1 will do? Go to same pointer arithmetics. If we are at initial stage, like AP is storing a base address 200, what AP plus 1 will do? It is quite complex. You might find it initially quite complex, but please, as much we are doing in a class, do practice that. If you have any query, anything coming to your mind, how it is happening, so why it is not happening in some other way, do bring that query to me. Okay. Now, what this will do? First, just tell me if I write this part will do AP plus 1. If we write AP plus 1, what changes it will make to AP? If we write, okay, pay attention. If we write AP plus 1, that means like incrementing, adding an integer constant. Fine. Integer constant is 1 in this case. So 200 value, this value will be 200 plus 2 into 1. Fine. 200 plus 2 into 1. So that is 202. And dereferencing at this address, which is the address because AP is a pointer, so we can dereference any memory address. Dereferencing at this address 202, that means 202 is the base address of element A1. Fine. At this address, put value 5. So here at element A1, we are putting value 5, that is at address 202. Indirectly, using the pointer, we are assigning value to element A1. Fine. Same way, with this expression, we are assigning value to A2 element, which is at address 204. How this 204 come up? 200 plus 2 into size of integer, that is 2. So 200 plus 2 into 2, so it is 204. At address 204, put value 5. That is the syntax of pointers and how we are playing with them when this is referring a array. So at second element of array, that is A2, we put it value 5 this way. We could do it this way, or we could simply write like A5. Sorry, second element, na? A2 equal to 5, semicolon. For this line, we could also simply write A1, that is the second element of array at index 1, equal to 5. Simple? Is this simple? It might not looking very simple at this point of time, but just do practice this much only. Jitna aapko samajh aaya, just do practice this one along with this example. Do practice this once, then we'll discuss. Continue from here next time. Fine? Fine? Because this is a very important topic and you should understand it in complete depth. So